Good morning. I am Gaurav Harne and I am having with me my colleague Mr. Dhaval Panchal. So we will be sharing our thoughts on how we can accelerate the performance of the packaging machinery by leveraging SOLIDWORKS simulation. So packaging machinery is a very big industry, we can say, correct? Not only glass but also packaging industry is used in each and every sector like paper packaging, cardboard packaging and so on. Now if I talk about the global consumer packaging industry, so around about 50% goes in the food and rest are like beverages 19%, healthcare 6%, cosmetics 5% and others 20%, which may include other industry sectors. The CAGR growth of Indian packaging industry has been growing from about 25%, right? If I talk about in last 5 years, so it is a very booming industry. So these are the various examples what I have set up. Packaging industries can be in the form of conveyors, they can be again in form of robotics can be used for the same, right? And we can even see packaging industry is used for in glass bottles and so on. So today's agenda is what are the big challenges in packaging industry, then 3D ecosystem streamlines development and manufacturing. So how the 3D modeling using SolidWorks we can design our packaging machines, right? As we know, the machines are very big. So with the help of kinematics and dynamics, we are having SolidWorks simulation motion available to check the movement of our machine, whether it is performing as per our needs, right? Then we have the validation part. So how we can validate our machines by using improved FEA technology, finite element analysis. So let us start by the first topic, that is the challenges. Now customers build large complex machines, correct? So the packaging machines, if we look, they are huge. So we need to be sure how we can design those huge machines without any interferences or without any manufacturing defects, correct? And they are difficult and expensive to make changes once it is built. The rework, if it comes, then it is very expensive to do all such things, correct? Sometimes what happens, the machine is not working as per our requirements or as per our needs. So right, so at the time of first run, the machine typically not how it should work. We get certain issues, correct? So with the help of motion we can run it virtually, right? And then be sure that after manufacturing, after assembling, it will work as per our requirements, correct? Large or complex systems are hard to control without a control feedback system and understanding of the machine dynamics, correct? Whenever there are huge movements in any machines, so we need to be sure that all the processes are going on smoothly. After completion of one task, the second task comes, after the completion of second and so on. So everything is interdependent. So to control huge machines where there are movement continuously occurring, so it is very important to check the dynamics of the machine as well. Now let me go ahead and make you understand how the 3D ecosystem streamlines the development and manufacturing of such huge machines. With the help of 3D CAD, the inbuilt functionality in SolidWorks, how easily we can manufacture such machines. So I would like to hand over the session to Mr. Dhaval Panchal. He will just take you through the 3D modeling part of the machines.
Okay. So as you all know, we will start with part model. Then we'll assemble a few further sub assemblies and models with that model we have created, right? And after that we'll see that how we can manage the whole plant layout of packaging right? So this will be our process that we follow for CAD modeling, right? So let us move towards SolidWorks, right? So for starting, we are going to create this structural object, right? So we will be focusing on how easily we can design our models using SolidWorks, right? So for that, let me just open a sketch, right? So in SolidWorks, we don't have to create each and every segment to create our structural members, right? So for that, I just need one center line sketch, right? And using that center line sketch, we can assign a various standard, right? For example, if I'm using ISO, and it also provides us the option of choosing a different structural members such as SB beam, square tube, rectangle tube, right? C channel. So there are many number of options that we can go through, right? As you can see here, there are different options according to our selections, right? So for now, I'm going to use ISO C channel, right, of size 80 by 80. So further, I just have to select a center line, and what SolidWorks does is it automatically assigns member to that segment. Further, we can also control that from which point I want to locate that profile, right, or shift that profile, or I can also rotate according to my needs, right? So that way we can also control uh, our design, right? After that, we can also assign a different structure members, such as I want to apply a square rectangular beam here. So that is also possible, right? So I'll just select the size and appropriate tubing for that. And all I have to do is select the sketch line, right? So as you can see how easily we can generate a structural members while using SolidWorks, right? For that, I don't have to apply or create a sketch each and every time, right? Further, after applying the segment, what if I want to trim, right? So for that also, we have a very powerful tool. We just have to select or assign a bodies that we want to trim, right? And after that, selecting boundaries, it will automatically trim that bodies which are further moving, right? So what is the difference of this weldment structure? So what it is doing is it is also generating a cut list property. Cut list properties means for as you can see, I have selected this C channel segment, so it will also highlight that particular beam, and it will also provide us information about that structural profile, right? So what is the length of that beam, right? What are the starting and ending angles, what is the material and total length or weight of material, so that can be accessible directly into a SolidWorks environment, right? So once our base model is ready, we are going to assemble, right, in such manner. So let me just show you that how easily we can assemble any product using SolidWorks, right? So for that also we can assemble any model with only clicks, right? As you can see, I'm on just clicks, I'm able to assemble that part, right? So this is how easily we can assemble or create part, right? Then next stage is we want to create a drawing, right? So drawing can also be done using simple clicks. For example, I want to create this bill of material table, right? So for that, I don't have to manually type each and every part, right? On single click, we can create our bill of material, right? And further we can also assign different properties, as you can see here, mass, material, or our custom properties also, right? So after creating a bill of material, there we do have option of exporting it as a different template, right? So what is the different like using a Excel, normal Excel, or exporting from SolidWorks, right? So whenever we are exporting using a SolidWorks, what it does is it also provides a thumbnail of each and every part, so it will be helpful to identify that part easily, right? Your procurement department or purchase department can easily identify that the motor is quantity of motor is this, or the segment or screw is we are going to order 31 quantity, right? So that way we can easily identify parts also, right? So this is just a method of designing and assembling and drawing. But what if we are using a huge layout of our whole process, right? A whole plant we are using like this, right? So at that time SolidWorks is also helpful, right? So we will see that how we can easily assemble huge plant like this, right? So for example, I want to create one more assembly line here, right? So for that I don't have to import or do anything, right? I can directly copy my assembly, right? And as you can see, I can directly snap it into its original position, right? So for that it won't take long, right? As you can see, I'm just copying that particular part, right? So now my assembly line is ready. Further I want to assign a robo, right? And at the end, wait a minute, okay, and at the end I want to also assign a person to appropriate location, right? Or appropriate station. So that can also be possible, right? So as you can see, I'm just dragging that person to appropriate location, and it snaps into its original location, right? So this is how we can work or design or create a whole plant, right, using SolidWorks. So further after that we will see more possibilities that what can be done, and that will be covered by Mr. Gaurav Harne, right? But apart from that, what are the benefits of using SolidWorks, right? So these are some benefits of using SolidWorks, right? As we have seen previously, that how fast or accurate we can design, generate 3D models, drawings, or complex parts, right? So that way we can also boost our productivity in such manner that will reduce our time of designing, right? We will reduce our rework time, so it automatically reduce our costing, that will affect, right? So by doing reworks and every time we are creating new parts, so that will also cost us much more, right? So that way we can also reduce our costing, right? We can improve our quality, and in such manner, right, we can directly get idea of where we are getting an interference, right, where the assembly is not matching properly, so we can directly reduce that process using SolidWorks, right? So that way we can also increase our innovation, right? So we can focus on our production part, right? So further Mr. Gaurav will take us through motion and analysis part. Please Gaurav, you can go ahead.
Thank you, Mr. Dhaval, for the elaborate presentation on the 3D CAD modeling. I hope I am audible. So
Yes.
yeah, thank you. So let me go ahead with the next topic, that is SolidWorks Motion tools. So as I have mentioned earlier, we want to check our models kinematics and dynamics, how it is working whenever it is in manufacturing process, correct? So how we can accelerate the performance of the machine by leveraging the SolidWorks Motion tools which are inbuilt available. So these are the few queries which might come in the minds whenever we design a assembly line machines. For example, can I find assembly dynamics with kinematics? Is it possible to get the operational interference detection, right? As we know, there are various movements occurring, whether it is linear motion, rotary motion, or any types of movement. So there should not be interference between those. There should be a sufficient space available so that the robotics arms can perform their work. So everything should be taken into account while we design such huge machines for packaging industry. So is mechanism operating speed within the limits or not? So we can find part, joint and assembly level reaction forces, loads and moments, torques, accelerations and velocities. So all these things can be find out. Now this is an example of a pick and place robot, right, which we have taken from one of the company. Its just work is to pick a thing from the table and it is just placing on a rotary table, right? So whenever it picks another part, the rotary table moves so that it gives the space to place the part. Now this is a very simple mechanism which we have tried to do the solid model inside the SolidWorks, and we have done the motion analysis as well. So let me just open the model. Yes, as you can see over here, so I have used various 3D modeling techniques. Now this is a sub assembly, main assembly, which consists of few sub assemblies in it, right? So as Mr. Dhaval have showcased us how easy we can do the modeling part, so that thing we have done over here, and we have the add-in for SolidWorks Motion which is available. Now the great part is, inside a single window we can perform our modeling part, we can perform our motion part, as well as we can perform our simulation part also, correct? So just I will activate the add-in and my motion capabilities will be available over here, correct? So over here you can provide motors if required, if there are rotating components inbuilt. There is even linear motor if you want to take into account actuators, correct? And motions can be given in the form of constant speed. You can provide distance, right? Also you can provide oscillating motions and so on, correct? You can even provide segments. So we have a huge database how you can provide the input of your motors to your system, correct? Also you can provide springs, dampers, forces, as well as contacts, correct? If there are more components which are going to touch each other, then contacts can be provided, as well as gravity, the most basic type of force which is occurring. So all these things can be provided. So if you look closely over here, I have provided few of the linear motors here, right? As this arm is going to move in X direction, Y direction, as well as in Z direction to pick and place the component. So likewise all the settings are provided here, correct? And the contact sets are also provided between the actuator and the product which it is going to pick, correct? And we can create an event based motion, right? So you can create your task. How are they going to be triggered? That thing can be even done here, right? And which feature is going to trigger those tasks, right? That thing can be associated with it, as well as the time, for how much seconds you want the action to be completed. So likewise, if I just run it, so you can see how easily you can create your motions for better understanding how your machine is going to work in the actual environment. Correct? So that if there are any issues or if there are any interferences occurring when this machine is being doing its task, that all things can be taken care well in advance, right? So there is no need to again do very tedious or costly reworks, right? So with the help of this motion tool, it is very easy to visualize your part or the mechanism even before it is being manufactured. So this is just a comparative study what I did. So at the left hand side you can see the actual machine which I had taken the video, and on the right side you can see I have done the motion analysis or the motion simulation of the same machine, of the pick and place mechanism. So it is very easy to design your products where there are huge movements coming inside your mechanism, correct? So these are the few more examples I can say how you can leverage the SolidWorks Motion tool in the packaging industry. Now this is an example of sorter. Now it is sorting the boxes as per the sizes. So I have applied those red color sensors on the top. So according to the size, it will just sort the boxes. That will trigger and it will be sorted in its respective base. Now another example is this assembly station overview. Correct. Now each assembly station is having its own work to be performed, right? So you can look closely. Such kind of motion simulations can also be done, also can be achieved with the help of SolidWorks Motion. Now this is another example, cap folding machines, where there are lot of movements inside the machine, and to take care of all these movements without any interferences was very difficult, right? But with the help of this motion, it was easy to understand whether there are any interferences coming inside, whether we need to change the design, whether it is required to change any dimensions, so that the final motion is done as per our requirement. So if I talk about the few benefits, so you can create your dynamic load studies, you can build database of event based loads, right? You can, with the help of various loads, you can do your motion studies, then motor sizing, what wattage of motor is required to trigger the mechanism. So all these things can be found out. You can optimize your springs, dampers, right? If there are any cam drives or latch mechanisms, right? And one of the best thing is you can transfer your SolidWorks Motion to your SolidWorks simulation, so that you can check whether the part which is performing its task, whether it would fail or not. What are the stresses, what are the displacements, what is the FOS of that part, correct? So you can transfer your SolidWorks Motion results to your FEA, and you can further perform the FEA analysis. Now the final topic of our webinar I would like to touch is validate your machines using improved FEA technology. Now to improve the product quality, right? Now what is the influence of simulation on quality, right? So with the help of simulation you can produce a reliable product, you can filter out weaknesses in your designs. So before even if it is manufactured, you can validate it, you can apply the loads, materials, and check whether it could sustain the its performance or not, right? So these are the few influences of simulation on quality. Now if I talk about influence of simulation on time, right? Now at the bottom you can see the basic project length. So at first the project is conceptualized, correct? So in any industry, this is very general project length which is followed. Then it is going ahead in the design stage, correct? Then it has been tested. After the design is ready, it is tested. So the physical testing of that design is done. Then it is manufactured and then it is delivered. But what if we need to quickly check multiple designs? It is very difficult to manufacture each and every design and then do the physical testing. So it is very much time consuming. Also it is very much costly. Correct? So you can detect the potential issues earlier in the design stage itself. So again, which will reduce your time. You can reduce trial and error process and the time spent on hand calculation to perform your simulation. So what we have done over here is we have reduced our project length and we have clubbed the designing and testing part together. So inside the SolidWorks software itself, we are doing the 3D modeling. Also, we will be doing the SolidWorks Motion and SolidWorks simulation together, right? And after the validation is done, it is given ahead for the manufacturing and then it is delivered. So this will again influence much more with respect to the time. And if I talk about the last, that is the costing part. So the global project cost will be reduced, the outsourcing cost will be reduced, correct? If there is a frequent requirement of simulation, so most of the companies, what they will do, they will outsource the simulation part. But what if you have in-house? So again, that thing can be achieved inside your manufacturing facility. You can cut material use, correct? You can optimize your product, prototyping cost, shipping cost and so on. So finally your quality and performance increases, your time reduces and cost reduces. So this was just an overview of the importance or the influence of simulation in product development, product designing. Now market trends have never been stronger before, right, for simulation. It has been proven by the broad design engineering and manufacturing industries that simulation helps launching new products to the market faster. The benefits have been proven and are multiple. Faster product development, less prototyping, more innovation, faster and informed decision on design. Another key factor is customer satisfaction in providing not only innovative but high quality products. The bottom line is that simulation helps you to be more competitive in your market. Correct? Now let us go ahead and check how we can implement or how we can make use of this simulation tool with the packaging industry, how we can relate this to the packaging industry. So you can find out the failure location and stresses. You can find out the FOS due to the loading conditions. You can check the deformation is within the permissible limit or not, correct? Instead of doing the practical testing with the help of strain gauge, right? So it can be done virtually inside the SolidWorks itself. Now just continuing on the same model what Mr. Dhaval have shown you, the conveyor assembly. So let me just open the model. Yes. Now this is my conveyor assembly in which the engines are to be transferred, right, from one end to another end, right. So again it has been created, sub assemblies are clubbed together and the main assembly is created. So we can look over here at the bottom, there are few actuators, there is a cylinder and there is this structure. Also there are rollers for transferring the engine from one part to another part. Then there is pallet which will hold my component, correct. So with the help of this SolidWorks Motion, I have just tried to create its motion, like how the rollers would be moving, whether the rollers would be able to take the weight of the components, right? How the actuators are performing its task, right? Whether they can lift such a weight. So all these questions can be answered with the help of validation. So you can look closely how the actuators actually raised the engine component, and it was transferred from, it took a 90-degree turn. So if I just zoom in over here, right. So I want to be sure that most of the weight which is been carried by these actuators to raise the component, whether they are safe or not, correct? So as I have previously mentioned, we have the option of simulation setup, right? So the structural simulation using motion loads can be done, right? So I have done a simple analysis of this lifting load which is coming on this actuators, on this linkage arm. So the first thing is you will have to apply material. So SolidWorks is having the inbuilt library of various standard materials available. You can also create your own custom library if required, correct? So I have provided the material as per the requirement, plain carbon steel. Then you can provide the fixtures, right? Whether there is a roller type of fixture, hinge type of fixture, and so on. Then the loads can be provided, right? And finally I will just run it and understand the results. So you can check here, I am getting the stress as 39 MPa, the maximum stress what I am getting on this linkage arm when it lifts the product. And if I talk about displacement, I am getting roughly 0.6. Also you can have a look at factor of safety. So FOS I am getting is 3, which is good enough, right, to perform its task. You can even reduce the weight if required. You can create cutouts over here if you want to optimize it so that your factor of safety can be within the range of 2.5 to 3, right? So all those optimization can also be performed in the SolidWorks simulation tool itself. So once you are sure that your product would not fail, right, then it is easy for you to go ahead and manufacture your product, right? So what we have seen, we have taken this actuator part which is playing very important role in taking the load, and we have done the FE analysis and checked its stress value, displacement value, and the factor of safety value when the load is coming on the part. Now moving ahead, if I want to check the strength of my structure, right, on which all the conveyors are assembled, right, so that thing can also be done. So let me just open the model again. Yes. So I have just removed all the rollers and I want to check the strength of this structure, correct? So over here I have created a few studies. So just you will have to add in your SolidWorks simulation tab. So all your simulation features will be activated, and from here you can create your new study. So not only static, but if you are interested in frequency analysis, if you want to check what are the natural frequencies of your component, even you can perform optimization studies, right? We have thermal, buckling, fatigue, and so on, correct? If you want to check vibrations coming under your product, so you can even go for dynamic analysis, etc. Correct? So once you select the study according to your requirement, so you can go ahead and apply all the boundary conditions. Like over here I have applied the materials, I have applied the fixtures at the bottom 8 legs. You can even apply the gravity load, and the distributed mass I have applied at the top of the structure. Now the distributed mass I have applied as 1000 kg, taking into account the weight of rollers, the weight of the components which are transferred over the rollers and so on. And finally you will get the results. Now the maximum stress I am getting over here is at the bracket, right, because the brackets are actually transferring the load, right, from the horizontal structure to the vertical structure. Still my assembly is within the permissible limit of 220 MPa. 220 MPa is the yield strength of my material, and the maximum I am getting is 101 MPa, which is within this limit, so it is safe. So you can check what are the displacements, right. Also if you want to plot your factor of safety, so you can go over here and you can plot the same as well. So let me just plot the FOS for this structure. I am getting 2.2, correct. Normally we keep the FOS according to the application between 2.5 to 3 or between 2 to 3, correct. Now what if I want to check what will happen if I change the load? Right now I have applied 1000 kg of load, but what if I change my load to 1000, 1500 or 2000 kg? So we have this very wonderful design optimization tool or design study tool which is available, where you will just have to type in the value of loads what you are interested to perform the analysis, correct. And once you run it, you will get the tabulated form of results. What are the stresses value and displacement value for 1000 kg, for 1500 kg and for 2000 kg, correct. So you can select the scenario, you can go back to your structural analysis study and you can check the results. So previously I was getting 2.2 factor of safety for 1000 kg, correct. So I have doubled the load. I am taking right now 2000 kg. Now obviously my factor of safety has come down to 1.3, correct. So dynamically you can perform or check the results. So if I take into account 1500 kg, so what will be my results? So you can check it over here, it has increased, right, to 1.7. So likewise it will make you comfortable at what load, right, it can sustain the weight, correct. So such kind of design studies can also be performed on your structures. So you can avoid failure and over design, right. You can design for calculated factor of safety. You can evaluate design changes very quickly, right. So if you want to change any dimension, you can directly go back to your model. Let me just open the model. As it has a very good associativity with the 3D CAD model, if you want to make any changes, you can just highlight the feature, make any changes required, come back to your simulation study and just run it, right. So it is having a very good associativity with the CAD as well. You can improve your product quality and report generation. You can create your automatic reports as well. So for report we have a pretty good tool. You can directly create your reports from here. So it will provide lots of information. You can even provide custom information like the designer, company address, logo and so on. And once you have created the report, let me just open the report. Yes, so this is my report. So it will give you all the detailed information starting from the material, what is the mass of each and every part, correct, what is the meshing condition you have used, what are the reaction forces, and finally the results. So everything will be created for you in the report. And I would like to come to the next part, that is one case study of the customer called Sidel India Private Limited, who is using our SolidWorks CAD, right, to create their designs. So it is a leading manufacturer of bottling and packaging machinery in India. So with the help of SolidWorks product development tools, SIDEL India has enjoyed faster, more accurate, large assembly design, right? Less error prone revision control and automated production of high quality product documentation. So this was the review what we got from one of our packaging industry customer base. So I would like to conclude my webinar. So if you have any query, you can contact us. So these are our marketing email ID and telephone number. And if you have any query, you can ask us. Thank you.